Welcome to aminacademy.com. In chemistry, let us discuss about trends in the periodic table. The arrangement of the elements in periodic table reveals trends in the properties of the elements. A trend is predictable change in a particular direction. For example, there is a trend in the reactivity of a alkali metals as you move down group 1. Understanding a trend among the elements enable you to make prediction about the chemical behavior of the elements. These trends in properties of the elements in a group or period can be explained in terms of the electron configuration. Next, we'll discuss about ionization energy. The reduction of the attractive force between a positively charged nucleus and its outermost electron due to the cancellation of some of the positive charge by the negative charge of the inner electron. When atoms have equal numbers of protons and electrons, they are electrically neutral because number of protons is equal to number of electrons. Electron have negative charge, proton have positive charge, so totally an atom is neutral. But when enough energy is added, the attractive force between the protons and electrons can be overcome. When this happens, an electron is removed from an atom. The neutral atom then becomes a positively charged ion. Here, we will discuss further. Suppose A is an atom plus we are adding ionization energy. Then a neutral atom becomes positively charged ion and negatively charged electron. So it is ion, this is electron. Ionization energy decreases as you move down a group. Ionization decreases when you move down to group. Here, each element has more occupied energy level than the one above it has. Therefore, the outermost electron are farthest from the nucleus in elements near the bottom of the group. Similarly, as we move down a group, each successive element contains more electrons in the energy level between the nucleus and the outermost electron. The inner electron shield the outermost electron from full attractive force of the nucleus. This electron shielding causes the outermost electron to be held less tightly to the nucleus. Now, further discuss about electron shielding. The reduction of the attractive force between a positively charged nucleus and its outermost electron due to the cancellation of some of the positive charge by the negative charges of the inner electrons. Now, further we'll discuss about ionization energy increases as you move across a period. From one element to the next in a period, the number of protons and the number of electrons increases by one each. The additional proton increases the nuclear charge. The additional electron is added to the same outer energy level in each of the elements in the period. The higher nuclear charge more strongly attracts the outer electrons in the same energy level, but the electron shielding effects from inner level electron remains the same. Thus, more energy is required to remove an electron because the attractive force on them is higher. That means ionization energy increases. Next, we'll discuss about atomic radius. The atomic radius of a chemical element is a measure of the size of an atom. Usually, the mean or typical distance from the center of the nucleus to the boundary of the surrounding shell of electron. Atomic radius decreases as we move across a period. Your atomic radius here increases while you move down to the group, and atomic radius is increasing towards left to right in period. We'll discuss about atomic radius further. Atomic radius increases as you move down a group. As you proceed from one element down to the next in a group, another principal energy level is filled. That means we are moving down, energy levels are one by one, it's filled. The addition of another level of electron increases the size or atomic radius of an atom. That means addition of an electron, that atomic radius will increase. Electron shielding also plays a role in determining atomic radius. Because of electron shielding, the effective nuclear charge acting on the outer electron is almost constant as you move down a group, regardless of the energy level in which the outer electrons are located. As a result, the outermost electrons are not pulled closer to the nucleus. Next, we will discuss about further atomic radius. The atomic radius decreases as you move across a period. As you move from left to right across a period, each atom has one more proton and one more electron than the atom before it has. All additional electrons go into the same principal energy level. No electrons are being added to the inner level. As a result, electron shielding does not play a role as you move across a period. Therefore, as the nuclear charge increases across a period, the effective nuclear charge acting on the outer electron also increases. This increasing nuclear charge pulls the outermost electron closer and closer to the nucleus, and thus reduces the size of an atom. Now, next, electro negativity. Electronegativity is a measure of an atom in a chemical compound to attract electrons. How much force this nucleus attract that electron, that is called electronegativity. Electronegativity decreases as we move down a group, and electronegativity increases as we move across a period. Atoms often bond to one another to form a compound. These bonds can involve the sharing of valence electrons. Not all atoms in a compound share electron equally. Knowing how strongly each atom attracts bonding electron can help to explain the physical and chemical properties of the compound. By using Pauli's exclusion principle, we can understand this. Here, the Pauli made a scale of numerical values that reflect how much an atom in a molecule attracts electrons, called electronegativity values. Now, electronegativity values generally decreases as you move down a group. However, electron shielding plays a role again, even though cesium has, for example, cesium has many more protons than lithium does. The effective nuclear charge acting on the outermost electron is almost the same in both atoms, but the distance between cesium's sixth principal energy level and its nucleus is greater than the distance between the lithium's third principal energy level and its nucleus. This greater distance means that the nucleus of cesium atom cannot attract a valence electron as easily as lithium nucleus can, because cesium does not attract an outer electron as strongly as lithium. it has a smaller electronegativity values. Next, ionic size and electron affinity. Further, electronegativity will discuss. The increase in electronegativity across a period is much more dramatic than the decrease in electronegativity down a group. Here, ionic size and electron affinity of an atom or molecule is defined as the amount of energy released when an electron is attached to a neutral atom or molecule in the gaseous state to form a negative ion. Electron affinity increases when we move upward along the column. Now, we will discuss other periodic trends in melting point and boiling point of an element. As we move across a period 6, the periodic trends for melting and boiling points goes through 2 cycles of increasing, reaching peak and then decreasing. That means the melting and boiling points for the elements in period 6 as shown in the periodic table. Notice that instead of generally increasing or decreasing trend, melting and boiling points reach 2 different peaks as D and P orbits fill. That means here, as we move across a period, the periodic trends for melting point is first, melting and boiling point goes through 2 cycles of first increasing and reaching the peak and then decreasing. Further details we'll discuss in more videos we have done. Please subscribe our YouTube channel.